This is the video for Shannon and Jacquelyn, and our project is about the physics of high jump.
This is our introductory video that explains the modern method of high jumping.
What's the secret behind the technique? It lies in a physics concept called the center of mass. For every object, we can locate the average position of all of its mass by taking into account how the mass is spread around the object. For instance, the center of mass of a flat rectangular object of uniform density will be in the intersection of both diagonals, in equal distance from each corner. We can find the center of mass for other objects by similar calculations, or by finding the object's balancing point, which lies right underneath its center of mass. Try balancing a broom by holding it and slowly bringing your hands together until they meet. This balancing point lies right underneath the broom's center of mass. We humans also have a center of mass. When most people stand up, their center of mass is around the belly. But what happens to your center of mass when you lift your hands in the air? Your center of mass moves upwards. It moves all the time as you move through the day, based on how your body is positioned. It can even move outside of your body. When you bend forward, your center of mass is located below your bent belly, in a place where there is no mass at all. Weird to think about, but that's the average position of all your mass. Many objects' center of mass are outside their bodies. Think of donuts or boomerangs. Now look at the Fosbury flop and follow the position of the center of mass of the jumper. The jumper runs very fast, so he can divert his horizontal velocity to vertical velocity, and jumps. Wait for it. There. Look at the jumper's center of mass as his body bends backward. It's below the bar. That is the secret behind the jump. With the old pre-Fosbury techniques, the jumper had to apply enough force to lift his center of mass above the bar by a few inches in order to clear it. The Fosbury flopper doesn't have to do that. The genius of the Fosbury flop is that the jumper can apply the same amount of force but raise his body much higher than before. That means he can raise the bar so high that even when his center of mass can't go any higher, his arcing body can. Fosbury's technique brought the high jump to new heights by splitting the jumper's body away from his center of mass.
Our research question is, how do you explain the physics of high jump? And it's actually just an equation that is U2 equals 2gh, where U is the speed of the jumper, G is the acceleration due to gravity, and H is the height of the center of mass. The higher the center of mass and the greater the speed of the jumper, the higher they will be able to clear. The different methods of high jumping will produce different maximum values for these variables.
There are three main methods that have been used over the years for high jumping. The original method was the scissor, following that was the Western roll, and finally the modern method is the Fosbury flop, which is the most effective method.
The scissor method originated in the early 1900s. The scissor kick is a technique in which the legs are lifted over the bar in alternation, one after the other. The reason this was a common method in old times was due to the fact that there was no landing mat and the jumpers needed to land on their feet. The advantage of the scissor technique is that it's easier for beginners and kids, and the disadvantage is that the center of mass must pass over top of the bar.
Mass clearing the bar, so technically it's harder, like you're getting your mass up higher in order to clear the bar.
Yeah, that would make sense.
Another method is the Western roll. In this technique, the athlete clears the bar on his or her side, with the takeoff leg tucked under the rest of the body, face down with the body stretched along the bar. The advantage of the Western roll technique is that it doesn't require a lot of flexibility, but again, the center of the mass stays in the area of the actual mass.
You've got half your body going over the bar all at once.
Yeah.
Whereas in the flop, my coach used to talk.
The Fosbury flop originated in 1968. The advantage of this technique is that it allows parts of the legs and the upper body to be lower than the bar at the peak of the jump when the hips are at the highest point. This allows the pelvis to rise to a greater height in relation to the position of the center of mass. The center of mass passes below the bar. People jump backwards because then there is a less probability that their arms and legs will hit the bar.
Clears the bar, but not all at once. So you're keeping like your legs and your arms sort of underneath the bar. If you average where your center of mass is, it's under the bar. Whereas like the other technique.
This is a quote from Dr. Jesus de Pena describing what the Fosbury flop is. The Fosbury flop specifically, its main known characteristic is that over the bar, you go on your back because you take off from the ground and your body is pretty much vertical. And you're facing more or less along the bar, and then you're going to be twisting about 90 degrees so that your back is pointing towards the bar. Also, you're going to be doing a partial somersault so that your shoulders go down, your legs go up, so the peak of the jump, you're on your back and horizontal and perpendicular to the bar.
The basic principles of high jumping are as explained in the introductory video. The location of the center of masses varies depending on the method used to jump. The definition of the center of mass is a point representing the mean position of the matter in a body or system. To the right, you can see the center of mass in the scissors, which is the top. The middle one is the Fosbury flop, and the Western roll is the bottom one.
Another physics concept that can be applied to high jumping is Newton's third law that every action has an equal and opposite reaction. So the high jumper exerts a downward force on the ground that exerts an equal and opposite upward force to the jumper to allow them to take off.
Newton's second law is also applicable in this concept.
The equation that is used for this is F equals ma, where ma is also equal to the ground reaction force minus the weight of the person. So when solving for the acceleration of a person's center of mass, you do the ground reaction force minus the weight of the person divided by the mass of the person.
Here are some facts about speed and other helpful tricks of high jump. The faster the jumper runs in their approach, the greater force they will be able to exert on the ground. Swinging the lead leg and arms will give the jumper more upward momentum. Leaning away from the bar at the ankle right as the jumper takes off will help them from hitting or leaning into it with their upper body. Since the takeoff is only 0.16 to 0.2 seconds, leaning away from the bar has little to no effect on the ability to clear the bar horizontally. The jumper's horizontal momentum forward will carry them into the pit after they take off.
As you can see by this diagram, right before the person takes off, they have a bend in their ankle away from the bar.
High jumping has a Celtic origin. Modern high jump began in the late 1700s as a physical education activity for children. In the 1800s, it became a competitive sport in England. And evolving from the scissor to the Western roll to the Fosbury flop, high jump has been revolutionized over the centuries.
Javier Sotomayor from Cuba is the current men's record holder with a jump of 2.45 meters, which is 8 feet and a fourth of an inch, set in 1993, the longest standing record in the history of the men's high jump. Stefka Kostadinova from Bulgaria has held the women's world record at 2.09 meters, which is 6 feet and 10 and a fourth inches since 1987, also the longest held record in the event.
These are the sources that we used for our presentation. Thank you for watching. Bye.